Assume David is 30 and he intends to accumulate $2.5 million in his RRSP by age 60. He expects his income and his contributions to keep pace with inflation, which we're assuming is going to be around 2.5% per year. Rounded to the nearest dollar, what's going to be his initial contribution at the end of the year if he assumes the RRSP will earn 8% compounded annually? Here, we're going to apply the following formula for constant growth annuities. And our goal is going to be to actually find the first payment, which we represent here by PMT. Let's go ahead and start filling in some of the values that we know. Here, we actually know that the future value that we're hoping or intending to accumulate is $2.5 million. We know that the interest rate that our RRSP will receive is 8% compounded annually, and our constant growth we're going to assume here to be 2.5% per year, or 0.025. If David's 30 now and he plans on making payments all the way up to age 60, he's going to make 30 contributions altogether, so n is equal to 30. Some of the expressions that we had inside the numerator and denominator of our fraction could be simplified a little bit, so I've gone ahead and done that to make this a little bit easier to put into our calculator. Let's start in the numerator of our fraction. We'll take our 1.08, we'll raise that to the power of 30, and then we're going to subtract 1.025, also to the power of 30. Let's go ahead and hit the equals button here, and I'm going to divide this by 0.055. This 144.81 is the number of that simplified fraction inside of the square brackets. Now what we need to do is we need to solve for the payment size, PMT. So we need to take our 2.5 million and we need to divide by this 144 number. So there's a couple different ways we can do this. We can use, for example, the 1 over x button and multiply. We can also take our 2.5 million and we can divide by second equals, which will recall back the last answer that we've done. And doing that division gives us $17,262.83. Now what we need to do is round this to the nearest dollar, so let's go ahead and round that up to $17,263.